Now link is essentially an abstraction. If I say people.orderby p.firstname, then I don't need to know the details of exactly how that sorting is going to take place. If the people collection is an in-memory list, then maybe some kind of quicksort algorithm is going to be used under the hood. And if people is an entity framework database set, then this is going to turn into an order by SQL statement, and the sorting will be performed by the database, maybe taking advantage of some indexes. And of course, the great thing about abstractions is that you don't need to worry about what the implementation is. You just say you want your data sorted or grouped or to calculate the maximum value, and you trust that whoever implemented the underlying code for methods like order by and group by wrote it in a sensible way. But the downside to this is that it's possible to write suboptimally performing code simply because you haven't really thought about what's involved in the underlying implementation of a function. Let me illustrate this with a simple example. Suppose we want to find if any orders have been refunded. Now, if you've followed the course along so far, hopefully you'll already know which link method can do this. The any method can answer this question for us. Are there any orders where the status is refunded? But quite often I'll see developers write code a bit like this. Count the orders where the status is refunded and see if the count is greater than 0. And many developers will write this sort of thing probably because they've forgotten about or maybe even didn't know about the any method. And this code will work and it will produce exactly the same result as the any version, but it won't perform as well. And the reason is obvious if you know what's going on under the hood. The any version is doing something like this. It's iterating through the sequence until it finds the first refunded order and then it breaks out of the loop. However, the version that uses while and count is doing something like this. It's iterating through the sequence and incrementing a counter whenever an order is refunded. And the difference is there's no break statement in this for each loop. So we always need to iterate through the entire collection of orders, even if there are millions of them and all of them have been refunded. Now, you might be thinking the performance difference between these two code snippets is going to be negligible unless you have a huge data set. But what if the lambda function we pass into the any method was potentially long running? For example, let's imagine that we're trying to find out if any orders are awaiting stock, and calling isAwaitingStock involves a call to a web API to query the status of the stock control management system. So in this case, it would be really wasteful to call the isAwaitingStock method any more times than we need to. And so in this case, the any version would outperform the while and count version by several orders of magnitude. Another performance pitfall with linked to objects is unnecessarily caching an entire sequence in memory. Now, several of the link to objects extension methods, such as order by, group by, and reverse, actually need to cache the entire input sequence before they can emit anything from their output. Let's have a quick look at a couple of code snippets that I've come across during code reviews. This one is trying to get the last item from an IEnumerable sequence by calling reverse and then calling first. And of course this works, but it's not really a very efficient way of doing it. Or here's another attempt I've seen trying to do the same thing, but this one's even worse because it not only caches it in memory, but it enumerates through twice. And of course, LINQ already has a perfectly suitable method, the last method, to solve this particular problem. But the point I'm trying to make here is that whenever you write a LINQ query, you should at least give some thought to what will be required to execute it under the hood. Will the whole sequence need to be evaluated? Will the whole sequence need to get temporarily cached in memory? And if so, is that really necessary? Or maybe there's another LINQ method or an extension method from MoreLink that can achieve the same results in a more efficient manner. But how can you know how a LINQ method is actually implemented under the hood? Well, the good news is that it's something you can find out quite easily. you can actually take a look at the source code for LINQ, and this is possible thanks to Microsoft open sourcing large parts of the .NET framework. So here on GitHub, at the .NET Core Effects project, I can see the code for the enumerable class. And I can learn from looking through this code that if I call reverse, then it uses this reverse iterator, which first ensures that the entire sequence is buffered into memory before returning the items in reverse order. Whereas if I call last, then I can see that it has a nice optimization, that if your sequence happens to be a list, it will just return the last element by index. But if it's not, it does have to iterate through the whole sequence, but it only needs to store a single item in memory to keep track of what the last item is. And so just by knowing even a little bit about how reverse and last are implemented, I can understand why calling people.reverse.first is not going to be as efficient as calling people.last. So whilst you can use LINQ without having any idea of how the methods are actually implemented, if you do have a basic grasp of what's involved in the implementations, then you'll be much better placed to avoid introducing performance problems. So last of all in this module, I want to consider the performance implications when we're running our LINQ queries against databases.